Think of your upcoming Cambridge physics exam, not as a memory test, but as a grand symphony. And you are the symphony conductor. Every single paragraph you write, every equation you balance, is an instrument that needs to play in perfect harmony to score those top marks. Welcome to this Exam Strategy Explainer. Today we are completely transforming how you approach kinematics. Whether you are sitting for syllabus 0625, 0651, 0652, 5054, or even building your foundation for A-Level 9702, speed, velocity, and acceleration are the absolute bedrock of mechanics. But here's the challenge. Let me tell you about two real students I worked with recently. First, we have Alex. Now, Alex works incredibly hard. When he sees a kinematics question, he just overloads the page with raw physics facts. He writes a whole novel about acceleration, throwing every formula he knows onto the paper, but there is zero actual analysis of the specific scenario. And then we have Sam. Sam is the opposite. Sam rushes. She sees a number, she sees the word calculate, and she completely misses the secondary command words like and explain. She gets the math right, but leaves half the marks on the table. Looking at their papers side by side, filled with red pen marks, it is so clear why they missed out on that A-star. They didn't orchestrate their arguments. Today, we are going to fix that.
To stop making the mistakes that Alex and Sam made, before we even touch a single formula or definition, we absolutely must start with this crucial question to build an application-first mindset. Ask yourself right now, what physical effect, measurement, or prediction actually depends on understanding these concepts? Think about it. Why do we even care about the difference between speed and velocity? Well, if engineers designing a roller coaster don't understand that velocity includes direction, meaning a sudden change in direction is a literal acceleration that creates massive g-forces on the human body, that ride isn't just going to be boring, it is going to be incredibly dangerous. When Alex dumped all those facts onto his exam paper, he failed to mention what was actually happening to the car in the question. When Sam rushed the calculation, she didn't predict the physical effect. By starting with the physical reality rather than just decorative formulas, you become far less dependent on rote memorization. You learn to reason your way through completely unfamiliar, tricky exam scenarios.
Here's our roadmap for this session, showing exactly how we will move from real-world reasoning straight through to scoring those top-tier marks. We will start with application-first physics, then break down the 4 steps to mastery, learn to safely translate our everyday language into strict physics vocabulary, map out some undeniable real-world connections, analyze the exam lens to stop losing those easy points, and finally lock it all in with essential memory prompts. We've got a lot of ground to cover, so let's dive right in.
Let's move into our first section and see how this builds our ultimate foundation. We need to look at exactly why real-world applications beat rote memorization every single time, especially when dealing with Cambridge's specific assessment objectives.
True mastery begins with a concrete example. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to it. When you are learning about acceleration, don't just immediately write down change in velocity over time and stare at the symbols trying to force them into your brain. Hold off on those symbolic relationships. Start with the everyday language. Imagine a car pressing hard on the gas pedal at a green light, or dropping a tennis ball from a second-story window. Feel what is happening physically. The object is covering more and more distance in each subsequent second. It's getting faster. Once you truly grasp that physical, undeniable concept, only then should you lock in the strict physics vocabulary. This gradual transition is the secret. It is what cements the knowledge so it doesn't just vanish the second you sit down in that high-pressure exam hall.
Now, what is really interesting about this next segment is the structured sequence it provides for tackling absolutely any mechanics topic the examiners throw at you. Let's look at the ultimate strategy reveal.
In the forces of motion chapter, speed, velocity, and acceleration act as a micro-gateway into a much bigger scientific pattern. To master this, we use the PEEL framework. Yes, PEEL, point, evidence, explanation, link. It is not just for English class, it is your secret weapon for physics. Step 1 on this slide, identify the quantity or phenomenon. That is your point. Are we looking at constant speed or changing velocity? Step 2, state the relationship involved. That is your evidence, where your formulas like V equals d over t come in. Step 3, explain the underlying physics. That is your explanation. Why is this happening? What is the actual cause? And step 4, connect it to an observation or device. That is your link. I want you to mentally test yourself right now. Look at a past paper in your mind. If you write an answer, does it have a point, evidence, explanation, and link. You have 30 seconds the next time you look at a question to mentally spot whether your answer follows Peel. By following this sequence, your answers act like that perfectly orchestrated symphony.
So how do we put this transformation into practice? Next, we need to look at how we safely translate our everyday observations into the formal cause and effect language that Cambridge examiners absolutely demand.
This is where we bring our student Alex back in to rewrite his answer live. Remember, Alex was just listing isolated facts. The crucial point here is to avoid exactly that. Whether you are discussing forces, circuits, waves, or kinematics, you have to build a clear cause and effect chain. An isolated fact is just writing, acceleration is 9.8 meters per second squared. That's not enough. Cause and effect, our physics success blueprint, is writing, because there is a constant resultant gravitational force acting on the falling object, it accelerates at 9.8 meters per second squared, causing its velocity to steadily increase. Boom! That right there is how a red pen mark transforms into a green check mark. Examiners don't just want to know that you memorized a random number, they want to see that you understand how one physical reality triggers another. I challenge you to take 60 seconds on your next study session to rewrite one of your old flawed answers using this exact blueprint.
And this perfectly transitions into how we handle data, which is where our second student, Sam, really struggled. If a physics problem involves graphs, and let's be real, in IGCSE 0625 it almost certainly will, you must be able to define exactly how the physical world dictates the shape of that line. Sam used to just write, the line goes up, grab the numbers, and rush to the calculation. No! Stress what the slope, area, direction, or shape means physically. For a speed time graph, the slope isn't just a mathematical calculation. Physically, it represents the acceleration. The area under that graph physically represents the total distance the object has traveled. Sam had to learn to slow down, look at the command word explain, and tie the geometry of the graph back to the actual physical reality of the moving object. That is how you secure full marks.
Before we brilliantly illustrate why these ideas matter far beyond the textbook with our interactive workshop, I have an important message for you. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams, IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams, IGCSE, and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the real-world connections.
Welcome to Challenge 1 of our interactive workshop, the data scan. You should always be able to pick at least one of these real-life scenes and explain exactly how the physics of motion applies. Let's take transport and safety. Imagine a complex data table showing car crash test results. You have 60 seconds on the clock in an exam to extract the core trend. Understanding the deceleration of that car isn't just an abstract math problem. It's the exact physics used to design crumple zones and seatbelts. These safety features are designed to save lives by increasing the time over which a collision occurs, which mathematically and physically reduces the peak force on the passengers. Whether it is scanning data for the orbital velocity of satellites in astronomy or the rapid acceleration of particles in medical technology, this physics is absolutely everywhere. Having these real-world examples in your back pocket is incredibly powerful for those high-mark structured questions.
Now let's move on to Challenge 2, Find the Flaw. We're going to apply this directly to the exam structure to ensure you aren't leaking easy marks.
This table is your ultimate cheat sheet. It contrasts the most common student errors with the safest methods. Let's find the flaw in how you might be writing right now. First weakness, writing a correct formula without explaining the variables. If you just jot down V equals D over T, you will likely miss a mark. The safest method? Provide the definition. Tell the examiner exactly what those letters represent in the physical world. Second weakness, quoting a process without linking it to a physical effect. Don't just say the car brakes. State the relationship. Say that applying a braking force causes a negative acceleration, which reduces the velocity. Finally, giving an example without physics justification. If you mention a skydiver's parachute, you must explain that it increases air resistance to balance the weight, resulting in a constant terminal velocity. For Challenge 3 today, I want you to do a speed writing drill. Give yourself a 30-second timer to write just one perfect Peel paragraph addressing one of these safest methods. It is an absolute game changer.
We are entering the final stage. Let's establish a completely foolproof system, combining our rules and memory prompts to test if your knowledge is actually secure before you ever walk into that exam hall.
Here is the complete physics answering system you need to adopt, driven by 3 non-negotiable rules. Rule 1. Command word decoding. Always know if they are asking you to state, calculate, or explain. Rule 2, Peel framework application. Structure your paragraphs like that symphony. Rule 3, the time management matrix. Spend your time strictly proportional to the marks available. And to lock this system in, you use these 4 memory prompts on the slide. Before you consider a topic done, ask yourself aloud. Number 1, what is the core idea? Number 2, what changes physically? Is distance changing over time? Number 3, what quantity or graph shows it? Can you vividly picture the speed-time graph? And number 4, where is it used in the real world? If you can answer these 4 revision prompts aloud, confidently applying your 3 rules, your grasp of the topic is absolutely solid enough to ace those structured questions.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I challenge you to look at the world through this new lens today. The next time you are in a car speeding up onto a highway or watching a plane take off, ask yourself exactly how the underlying physics dictates the outcome. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep questioning, keep observing, and go orchestrate that perfect exam symphony.